Hello students, in this video session I am going to discuss about the capacitor. It is 12th class syllabus. In capacitors connected in series, connected in parallel, how to find energy stored in capacitor and charge stored in capacitor, combination of series and parallel connection, and on what factors capacitance of the capacitor depends, we'll discuss. Most of the discussion only on parallel plate capacitor. Once key is closed in the diagram, see the positive terminal connected to the one of the plate, negative terminal of a battery connected to the one of the plate, so that electric field will be established between the positive plate and negative plate. Actually, what is capacitor? Capacitor is an electrical device which is used to store the charge. Why capacitor developed? Capacitor developed to store the charges. Whenever you require a charge in a part of the circuit, you can draw from that capacitor. Now, capacitance of the capacitor depends on what factors? Depends on area of the plate. More the area, more capacitance. And distance between the plates, least the distance, more the capacitance. And medium present between the plates of the capacitor. The capacitance of the capacitor depends on the medium present between the plates of the capacitor and the dimensions of the plates of the capacitor. Only these factors. It does not depend on the charge and it does not depend on the battery to which it is connected. The capacitance of the capacitor is fixed. It is like 1 liter bottle. The capacitance of the 1 liter bottle is 1 liter. That's it. If it is even empty also, I can say its a capacity is 1 liter. If only 500 ml filled, rest of the part is still empty, I can say capacitance of the bottle is 1 liter only. Like that, the capacitance of a capacitor also does not depend on how much charge you stored, to what battery, to which potential it is maintained, does not matter to find the capacitance of the capacitor. So capacitance of the capacitor fixed, for a given capacitor is fixed. It depends on what medium present between the plates of capacitor and area of the plates and the distance between them. You can write the relation between charge, capacitance and potential also. That is Q equal to CV or C is equal to Q by V. At low potential, you can store more charge. That you have to remember. At low potential, you can store more charges. Now I am moving to series connection of the capacitance. See, now it is connected to the potential of V. Let me change the color once. See, it is connected to the potential of V. Now this is the capacitance C1, C2 and C3. In series connection, charge on each capacitor is the same. Charge is same on each capacitor, irrespective of capacitance. One is heavy capacitance, at low capacitance, doesn't matter, as long as those two are connected in series, charge remains the same. You know Q is equal to CV. Now charge is the same. Then potential drop. Now potential drop across the each capacitor. You can write V1 is to, V2 is to, V3 is reciprocal of their capacitances. Reciprocal of their capacitance. Okay. Now what is the effective capacitance? If effective capacitance is 1 by Cs is equal to 1 by C1 plus 1 by C2 plus 1 by C3. This is a capacitance, the way to calculate effective capacitance when they are connected in series. How to identify? Point number 1. Charge remains the same on each capacitor and potential divides with the reciprocal of their capacitances. If n identical capacitors, each of capacitance C connected in parallel, so that effective capacitance is C by n. Effective capacitance decreases. Effective capacitance decreases when you connect the series connection. Sir, where we use this? See, in some part of the circuit, two capacitances are available. You want to use both the capacitor, but net capacitance will be lesser amount you want. Then you connect the series connection. And moreover, when you connect the capacitor in series connection, effective capacitance is less than the least capacitance. Let's suppose you have 2 microfarad and 3 microfarad. Let us suppose 6 microfarad connected in series. So effective capacitance is less than the least value, less than 2 microfarad. If you want to reduce the capacitance, connect them in series. Right? Now connect to the parallel. In case of a parallel, potential drop across each capacitor is the same. You know, Q is equal to CV now. Now potential is the same. Then charge divides Q1 is to Q2 is to Q3 is what you know, C1 is to C2 is to C3. So here charges store the capacitance depends on the capacitance. The more the capacitance, you can store more the charges in the case of parallel connection. If capacitors are connected in parallel, Cp is equal to C1 plus C2 plus C3. Effective capacitance increases. Similarly, like 2 microfarad and 3 microfarad and 4 microfarad connected in parallel. Now effective capacitance is greater than the greatest capacitance. Greater than the greatest capacitance. If you connect n identical capacitors, each of capacitance C0 in parallel connection, then it will be NC0. Capacitance increases. This already, you know this idea, you have an idea on this, more concentration and how to solve the problems based on connected in series and connected in parallel. Now see, this is one of the JEE mains question. Now look at this, the equivalent capacitance between A and B in the given circuit. How many capacitors we have? 1, 2, 3, 4, 5 and 6. Well, now see, look at this. I am talking about these two capacitors. See, this plate is connected to this point. Let me take this is C, and this plate also connected to C. So between these 2 points, no potential difference. No potential difference. Both are maintained at the same potential. Then no charge stored on these 2 capacitors. Now remove these 2. Now come to this. This is a plate 1 connected to A. Plate 2 connected to C. Okay. And plate 1 connected to C. And plate 2 is connected to A, and this is connected to A, and this is connected to C. If you redraw the circuit, let us suppose this is A, this is first capacitor C1, this is C1. One is connected to A, another one is connected to C, like that. This is second capacitor and this is third capacitor. This is C1, this is C2, this is C3. 1, 2 and 3. These 2 are no charge reside on these 2. No charge will be stored. And leftover, now this is point C. Remember, this is point C. This is point C. Now this plate is connected to the point C, and second plate of the capacitor connected to B. Now this is B. You have to redraw the circuit. By looking at this, don't think like all are connected in series. Don't remember like side by side is series, one over other is parallel. No, that is in a very beginning of the classes to identify for very first problem. They'll explain like that to get more idea. That's it. You don't think all capacitors connected in a line by line or connected in a line by line, those are connected in series. Not like that. Now this is the case C. Now look at the circuit. C1, C2, C3 connected in parallel, so that effective capacitance becomes all of same capacitance. So n identical capacitors connected in parallel, effective capacitance becomes NC. So how many capacitors? 3, each of 8, so that this becomes 24. And one more capacitance, it is 8. Now these 2 are connected in series. So series, you know, C1 C2 by C1 plus C2, otherwise 1 by C1 plus 1 by C2. Simplify, same thing, you will get it. 24 into 8 by 24 plus 8 is 32. 8 ones, 8 fours, 4 ones, 4 6. So answer is 6 microfarad. Answer is 6 microfarad. Moving to the next question. In the given figure, the total charge stored in the combination, total charge is 100 microcoulomb. The value of x, look at this, the value of x, how those are connected? As simple as that, they are connected in parallel. So total charge, here charges, you can say it is q1 here, q2 here, q3 here. He mentioned q1 plus q2 plus q3 is 100 microcoulomb, 10 power minus 6, right? Q is equal to CV, all are connected in parallel. So you can write 2 into 10 power minus 6 into 10, this is q1. Simple, otherwise I can take 10 common, that is better. Otherwise, okay, no problem. Now it is x into 10 power minus 6 into 10. I'm talking about the q2. q3 is how much? 3 into 10 power minus 6 into 10. If you take common, 2 plus x plus 3 is equal to into 10 power minus 6 into 10 is equal to 100 into 10 power minus 6. This is the total charge. That's what mentioned here. So 10 power minus 6, 10 power minus 6 gone. So you left with the 10. So answer is 5 plus x is equal to 10. Then x is equal to 5. X is equal to 5. He asked only x. Already given x is μf. Don't write 5 into 10 power minus 6. This is x value is the 5. Right? Every time don't expect like connecting finding effective capacitance only. Not like that. Now, 4 identical rectangular plates of length 2 centimeters. Remember that, length 2 centimeter, breadth 3 by 2 centimeter are arranged as shown in the figure. The equivalence capacitance is also given between A and C. Remember, between A and C is a capacitance across AC is given as x epsilon naught by D. Now find the x. Now redraw the circuit. Between A, C, I can say this is C1, C2, C3. Okay. Now between A and B, I think you can write this is C1, this is A, and this is B. Okay, now B is connected to C2. Now this B is part of C2. This is C. And B and D are maintained at the same potential. So this one. Now you can say this is a C. You redraw it. So this is B and this is D. B and D are connected. Okay, B and D are connected. And the plate with C, with C2 and with C3. This is a common plate for C2 and C3. Now you have 3 capacitors. Out of 3, 2 are parallel, 1 is in series. You can say this is C. All are identical capacitance. How do you know? Identical rectangular plates. So connected in parallel, it is 2C. Now these two are in series. If these two are in series, you can say C effective. You can cite CP is equal to C1 C2 by C1 plus C2. Correct? These are in series. So C and C gets cancelled. You left with 2C by 3. What is C? C is epsilon naught A by D. Now you know what is A value. Here let me change the color. See what is A value. A is length into breadth. Now rest of the value you can write. This is CP is equal to 2 by 3 epsilon naught. Length given as 2. Breadth is given as 3 by 2. Distance between them is D. So 2 and 2 gets cancelled. Final answer is how much? Cp is equal to 2 epsilon naught 2 into 3 6, sorry, 6 epsilon naught by 3d, or 3 ones and 3 twos. So Cp can be written as 2 epsilon naught by d. So x value is how much? 2. He asked x. So x value is how much? 2. So this is also one of the important type only, because only plates given. With 4 plates we can make 3 capacitor. With n plates we can make n minus 1 capacitors. Like we have 4 plates, that's why 3 capacitors. Got it? Now moving to the next question. Now look at this question. C1, C2, C3, C4, C5, C6 values are given, and he asked charge stored on capacitor C4. You want to calculate charge stored on C4. How to solve this? First step, I'll calculate effective capacitance of this. Once I calculate effective capacitance of this, effective capacitance of 3rd, 4th, 5th in parallel with the C2. Now then the potential drop across C2 is same that of this. So once the potential is known, we can calculate the charge. Now let me take effective capacitance of this. C3 is 2, C4 is 4, C5 is 2. Let me do that. All are connected in series. So 1 by 2 plus 1 by 4 plus 1 by 2 becomes 4 LCM. 2 plus 1 plus 2, it is 5 by 4. Effective capacitance of this, let me take that effective capacitance as C0, that is 4 by 5. Let me redraw the circuit again. Capacitor 1, capacitor 2, capacitor 6, and this is effective capacitance of all this. This is 4 by 5, and this value is given as 2, and C2 is given as 0.2, and C6 given as 2. Now look at this. These two capacitors are connected in parallel. So parallel simple addition, 4 by 5 is 0.8. So 0.8 and 0.2, it becomes 0.1. So this is 2. So 0.2 and 0.8 becomes 1, and this is 2. This combination connected across 10 volt battery. Now potential drop across 1 is same that of potential drop across 0.2 and across 4 by 5 also. Let me calculate. All are connected in series, so that V1 is to V2 is to V3, right, is a reciprocal of their capacitances. Here C1 value is 1 by 2. C2, don't take C2 from this value. Go here, this is C2, that is 1. C3 is again 1 by 2. So this ratio you can write as 2 is to 1 is to, sorry, this ratio you can write as 1 is to 2 is to 1. I want this. So total potential is 10 into, I want 2 parts out of 4 parts. So I'll get 5 volt potential drop. Nothing but 5 volt potential drop. Nothing but here 5 volt and here also 5 volt potential drop. Nothing but across this combination. Which combination? Across C3, C4, C5 potential all put together 5 volt. All are connected in parallel. If all are connected in parallel, charge on C3, charge on C4, charge on C5 is the same. Simply you can write as simply Q is equal to C into V. You calculated how much you got? 4 by 5 multiplied with the potential 5 and 5 gone, nothing but 4 microcoulomb. 4 microcoulomb even across C3 also 4 microcoulomb only. Across C5 also 4 microcoulomb only. Across C4 also 4 microcoulomb only. Because all are connected in parallel. This kind of questions 100% you can expect in JEE Mains. This is one of the JEE Mains question only. Now moving to the next question. This also is interesting only. A capacitor is made of a flat area A and a second plate having a stair-like structure as shown in the figure. The area of the each stair is A by 3. Height is D. The capacitance of the arrangement. Now you look at the capacitance. I can say this capacitance. See, this is one capacitance. That let me take C1. What is C1? C1 is equal to epsilon naught A by D. So you can write as epsilon naught A by 3D. Now this is second capacitance. Now look at this. This is the second capacitance. I can write C2 is epsilon naught. Area is A by 3. But distance between them is what? 2D. So you can write 2D. So you can say right epsilon naught A by 6D. Similarly C3 epsilon naught area of the plate is A by 3 only again. But distance between the plates, see this plate and this plate, distance between them is 3D by 3D. So simply you can say epsilon naught A by 9D. So you have one capacitor C1, C2 and C3. All are connected what? In parallel like this. All are connected in parallel. See, if all are connected in parallel, simple addition. Epsilon naught A by D is common. So 1 by 3, 1 by 6, 1 by 9. So you can take LCM is 18. 6 plus 3 plus 2. Epsilon naught A by D, which gives you 9 plus 2 11. 11 epsilon naught A by 18D. So option D is correct. Option D. Before leaving, please subscribe our YouTube channel Time for IIT, JEE and NEET to get to what you can watch more videos on very short videos and single concept. It is not like very lengthy video. Let us suppose you have a doubt on only on series connection, you can find one video in this channel. Or you have a doubt only on how to calculate moment of inertia of about different axes, we have a one video. So you want to go through any short particular topic, then you can search in that. That's why please subscribe this and watch videos also. Thank you so much.